Okay, I'm Bella Amasano and this is my math project. So we're going to start off with the problem. I'll make sure you can read it. What is the probability that a swimmer does backstroke given they go to Cartersville? What is the probability a Cartersville and Cass swimmer do backstroke? Making sure you can see. So first what we need to do is analyze our data. As you can see, this is the sample space, the cane swimmers, the woodland swimmers, and the Cass swimmers. There's going to be 13, 9, and 7. Here is a frequency table, and let me zoom in on that. There's your totals of each. There's the strokes, and there's the schools. Now, we are going to analyze. What is the probability that a swimmer does backstroke given that they go to Cartersville? So, we're going to start our work. You would look at the Cartersville swimmers that do backstroke, which is going to be 3 of them out of the total, which is going to be 9. Let me go ahead and bring that back up to you real quick. As you can see, there are 3 Cartersville swimmers doing backstroke and 9 total doing backstroke. So because it says given, you have to do the formula. And that would be A given B over B. That equals, so A and B is going to be a swimmer that does backstroke given that they go to Cartersville. So you match it up on the frequency table, which is right there and right there. So your number would be 3 on the top. And then your B is going to be the total, which would be 9. When you do that, you get the number 0.33. So that is going to be our probability that a swimmer does backstroke given that they go to Cartersville. And if you would like to, you could change that into 33%. That is how we would solve that conditional probability problem. Now, let's look at the second one. What is the probability a Cartersville swimmer and a Cass swimmer do backstroke? So this one has and in it, so we will multiply. So you're going to look at Cartersville, which is 3, and because this one is and not conditional, you're going to look at the total number of swimmers, which is going to be 29, as you can see on the chart. 29 total swimmers. Isn't the nifty movable board great? So we're going to start with work number 2. And the formula for this one is basically just multiplying the 2 probabilities. So our first one is that a Cartersville swimmer, so we're going to look at the Cartersville, 3 over 29. And then because it says and, we're going to multiply. See? I have the beginning fraction. Let's do a little line right there to separate. This is the second problem. So we have 3 over 29. Then it says a Cass swimmer, so we're going to look at Cass, and the amount of Cass people that do backstroke is 4, as you can see in the first one. And the total would still be 29, so we keep the same denominator, but change the top to 4. So when you do that, you get a nifty fraction, which is going to be 12 over 841, and that as a decimal is 0.01 or 1%. So it is realistically kind of unlikely, well, really unlikely, that a Cartersville and a Cass swimmer would do backstroke. There's my presentation. Oh, that was not good. Thanks. Hope you learned